Hello everyone, this is Jay from Monash University, Australia. Our research is supported by CSIRO and Data 61. Before I dive into our research, I would like to talk about trust. Before I talk about trust, I would like to introduce optimization. Optimization is an important tool in decision support. A real-world example of an optimization problem is to maximize profits and minimize costs within a business. Speaking of trust, which has various implications from different domains, from automation, performance, process, and purpose, are the general basis for trust. From artificial intelligence or AI, recently there are considerable interest in explainable AI with the aim to provide human understandable explanations to increase user understandings and trust of AI systems. Finally, in the context of optimization, researchers have investigated explainable optimization and suggested increasing user trust through user interaction. However, most user studies focused on solution quality and time spent when it comes to solution evaluation. This is why we want to understand trust in optimization systems from two specific aspects: feedback and interaction. In terms of feedback, it refers to showing the optimization solver progress. More specifically, we displayed the current solution each time the optimization solver found a better solution, together with the associated objective function value. In terms of interaction, we allow the user to explore and modify a solution returned by a optimization solver. Plus, there is an additional re-optimization function to further improve solutions automatically. We did two controlled studies to investigate the effect of feedback and interaction on trust, one effect per study. In both studies, we presented a vehicle routing problem with time windows. We applied a real-world scenario to make it easy enough to understand and explain. The scenario was about a company that sent electricians to customers. The goal of the optimization is to find a schedule allocating all customers to electricians with the overall distance traveled minimized. We built a browser-based visual interface for use in both studies. In the first study, we examined whether feedback on solver progress affects user evaluation of solution quality and trust in the optimization solver. The study was a mixed design with three factors: expertise, feedback, and solver quality. We recruited 28 participants. Half of them were optimization experts, the other half were not. Each participant was asked to evaluate solutions produced by good and poor solvers with and without feedback. The most important finding from the study is that providing feedback on intermediate solutions can increase trust for poor solvers. But such increased trust is unwarranted. This suggests that we need to be cautious about providing feedback to increase system transparency and user trust in optimization tools. Over-trusting a poor system is dangerous. In the second study, we investigated whether trust is affected by allowing the user to interact with the solution in order to better understand its quality. The interface looked similar to the first study. We added additional medium solver between the good and poor to support better solver comparison. Again, it was a mixed design with three factors: condition, expertise, and solver quality. We had three experimental conditions: no interaction, fully manual interaction, and manual interaction with re-optimization. We recruited 30 participants with 10 participants per condition. They were asked to evaluate solutions produced by different solvers under a specific condition. What we found is that interaction does lead to better calibrated trust. Specifically, trust increases when the user cannot find a way to improve the solution returned by the solver, but decreases when they can. It reflects the dynamic nature of trust. It also shows that trust can be earned via verification. This is why people say trust is an earned property. Participants reported that interactions make it easier for them to verify solutions. Re-optimization can also help them easily identify suboptimal solutions. This explains why semi-automatic interaction leads to the greatest trust in a good solver and the least trust in a medium poor solvers, whereas no interaction leads to the lowest trust in a good solver and the greatest trust in the poor and medium solvers compared with the other conditions. Here are some quotes from participants. In particular, I like this one. Verifying makes you confident. Confidence leads to trust. Last, in the future, there are several directions we can explore. We would like to investigate whether explanations of how the optimization solver works can build trust. It would also be interesting to see how interactive visualizations can be used to improve system transparency.